Hello students, in the previous lecture I have given an overview of this course. Then we have discussed about the decentralization with the help of a use case and finally defined what is a blockchain. So in our today's lecture we are going to start with the history of blockchain. Let us discuss the timeline of blockchain evolution. In 1991, research scientists named Stuart Haber and Scott Stonnett introduced blockchain technology. These scientists wanted some computational practical solutions for timestamping the digital document so that they could not be tampered or misdated. So both scientists together developed a system with the help of cryptography. Later in 1992, Merkle-Tree formed a legal corporation by using a system developed by Stuart Haber and Scott with some more features. Hence, blockchain technology became efficient to store several documents to be collected into one block. Later in 2000, Stephen published his theory of cryptographic secure chain plus ideas for implementation. In the year 2004, cryptographic activist Hal Finney introduced a system for digital cash known as reusable proof of work. This step was the game changer in the history of blockchain and cryptography. This system helps others to solve the double spending problem by keeping the ownership of token registered on a trusted server. After 2008, Stuart Nakamoto conceptualized the concept of distributed blockchain in his white paper, a peer-to-peer electronic cash system. He modified the model of Merkle-Tree and created a system that is more secure and contains the secure history of data exchange. His system follows a peer-to-peer network of timestamping. His system became so useful that cryptography became the backbone of blockchain. After that, the evolution of blockchain is steady and promising and become a need in various fields. In 2009, Stuart Nakamoto releases Bitcoin white paper. Blockchain technology is so secure that the following surprising news will give the proof of that. A person named James Howells was an IT worker in the United Kingdom. He starts mining bitcoins which are part of blockchain in 2009 and stopped this in 2013. The year 2014 is marked as the turning point of blockchain technology. Blockchain technology is separated from the current currency and blockchain 2.0 is born. Financially and other industries started shifting their focus from digital currency to the development of blockchain technologies. In 2015, Ethereum Frontier Network was launched, thus enabling developers to write smart contracts and apps that could be deployed to a live network. In the same year, the Linux Foundation launched the Hyperledger project. The word blockchain is accepted as a single word instead of two different concepts as they were in Nakamoto's original paper in the year 2016. The same year, a bug in the Ethereum code was exploited, resulting in a hard fork of Ethereum network. In the year 2017, Japan recognized Bitcoin as a legal currency. Block One company introduced the EOS blockchain operating system, which was designed to support commercial decentralized application. So slowly the blockchain emerged, and in 2020-22 Ethereum has shifted from proof of work to proof of stake consensus mechanism. The original Ethereum mainnet merged with Beacon chain, which has proof of stake Now it is existing as one chain. Let us discuss about the features of blockchain. Immutable. Immutable means that the block is a permanent and unalterable network. Blockchain technology functions through a collection of nodes. Once a transaction is recorded on the blockchain, it cannot be modified or deleted. We have already discussed in the previous video. This makes the blockchain an immutable and tamper-proof ledger that provides a high degree of security and trust. Every node in the network has a copy of digital ledger. To add a transaction, every node checks the validity of the transaction, and if the majority of the nodes think that it is a valid transaction, then it is added to the network. This means that without the approval of a majority of nodes, no one can add any transaction blocks to the ledger. Any validated records are irreversible and cannot be changed. This means that any user on the network won't be able to edit, change or delete it. So the next feature is distributed. All networks participate have a copy of the ledger for complete transparency. A public ledger will provide complete information about all the participants on the network and transactions. The distributed computational power across the computers ensure a better outcome. So distributed ledger is one of the important feature of blockchain due to many reasons. Like in distributed ledger, tracking what happening in the ledger is easy as changes propagate really fast in a distributed ledger. Every node on blockchain network must maintain the ledger and participate in the validation. Any change in the ledger will be updated in seconds or minutes, and due to no involvement of intermediates in blockchain, the validation for the change will be done quickly. The next thing is, if a user wants to add a new block, then other participating nodes have to verify the transaction. For a new block to be added to the blockchain network, it must be approved by a majority of the nodes on the network. Finally, in a blockchain network, no node will get any sort of special treatment or favor from the network. Everyone will have to follow the standard procedure to add a new block to the network. So the next feature is decentralized. Blockchain technology is a decentralized system, which means that there is no central authority controlling the network. Instead, the network is made up of a large number of nodes that work together to verify and validate transactions. Each and every node in the blockchain network will have the same copy of the ledger. The decentralization property offers many advantages in the blockchain, and I am going to list those advantages. The first advantage is, as a blockchain network does not depend on human calculation, it is fully organized and fault tolerant. The second advantage is, the blockchain network is less prone to failure due to the decentralized nature of the network. Attacking the system is more expensive for the hackers, hence it is less likely to fail. There is no third party involved, hence no added risk in the system. The fourth advantage is the decentralized nature of blockchain facilitates creating a transparent profile for every participant on the network. Thus, every change is traceable and more concrete. Finally, users now have control over their properties and they do not have to rely on the third party to maintain and manage their asset. The next feature is secure. All the records in the blockchain are individually encrypted. Using encryption adds another layer of security to the entire process on the blockchain network. Since there is no central authority, it does not mean that one can simply add, update, or delete data on the network. Every information on the blockchain is hashed cryptographically, which means that every piece of data has a unique identity on the network. All the blocks contain a unique hash of their own and the hash of the previous block. Due to this property, the blocks are cryptographically linked with each other. Any attempt to modify the data means to change all the hash IDs, which is quite impossible. The next feature of blockchain is consensus. Every block has a consensus to help the network to make unique and unbiased decisions. Consensus is a decision-making algorithm for the group of nodes active on the network to reach an agreement quickly and faster and for the smooth functioning of the system. Nodes might not trust each other, but they can trust the algorithm that runs at the core of the network to make decisions. There are many consensus algorithms available, each with its pros and cons. Every blockchain must have a consensus algorithm, otherwise it will lose its value. The sixth feature is anonymous. All the network participants agree to validate of the record before they can be added to the network. When a node wants to add a block to the network, then it must get majority voting, otherwise the block cannot be added to the network. A node cannot simply add, update or delete information from the network. Every record is updated simultaneously and the updation propagates quickly in the network. So, it is not possible to make any change without consent from the majority of nodes in the network. The seventh feature is faster settlement. Traditional banking systems are prone to many reasons for fallouts, like taking days to process a transaction after finalizing all settlements, which can be corrupted easily. On the other hand, blockchain offers a fast settlement compared to traditional banking system. This blockchain feature helps make life easier. Blockchain technology is increasing and improving day by day and has a relay bright feature in the upcoming years. The transparency, trust and tamper-proof characteristics have led to many applications of it, like Bitcoin, Ethereum, etc. It is a pillar in marketing and making the business and governmental procedures more secure, efficient and effective. So after seeing the features of blockchain, now we are going to discuss about the important blockchain terminologies. The first terminology what we are going to discuss is of a node. A node is nothing but of a member of blockchain network. So the next terminology is address. An address is a string of alphanumerical characters which identify an entity in the blockchain network. It is used to send and receive the cryptocurrency transactions. Next terminology is distributed ledger. A ledger is maintained on many nodes in a decentralized network. The records are stored in a chronological order. This ledger can be of two types. One is of permission and other is of unpermission, based on who has the access to view the ledger. The next terminology is peer-to-peer. As the name suggests, the peer-to-peer is nothing but of interaction that happens between two peers, that is parties or entities in a highly interconnected network. Block. A block is a data structure that contains all the necessary metadata about the block. Block header itself and contains the transaction. The first block in a blockchain is called the genesis block. Block height. Block height is the number of blocks contained in the blockchain. Block height is a usually measure of the amount of data in the blockchain. Blockchain, a chain of blocks which contains some metadata about the block, some transactions and joined to the previous block by the previous block hash value. Block Explorer, a tool to see statistics of block in a blockchain. Hash. Hash is a function with an encryption that captures an arbitrary length input string and computes a fixed length output. Hashes are created using a hashing algorithm that uses cryptography to form a one-way function. This means that hash theoretically cannot be retrieved without a key. Performing a hash function on the output data in a blockchain is termed as hash. It is used to verify the cryptocurrency transactions. Hash rate. It is nothing but of the performance of computer mining is measured in hashes per second or hash rate. Cryptographic hash function. A function that takes a variable size input and output is fixed size unique value. SHA-256 algorithm is a cryptographic hash function. Mining. Mining is a process of solving a complex mathematical problem in order to attach the new block of transaction to the blockchain. This term is used in reference to blockchain that uses proof of work as consensus mechanism. Difficulty. Hardness with which a new block of transaction can be connected to the blockchain. Block reward. Reward that is given to the entity which connects the new block to the blockchain. In case of Bitcoin, miners get reward of 12.5 Bitcoin for attaching new blocks to the blockchain. In case of Peercoin, miners get a reward of 42.64 Peercoins for attaching a new block of transaction. Cryptocurrency, a form of digital asset which is regulated and transacted on the blockchain network. Encryption techniques are used to regulate the cryptocurrency, hence the name. Satoshi, the smallest recordable unit of currency in the Bitcoin. Currently, a Satoshi is equal to 0.0002616 US dollars. Altcoin, an alternate to Bitcoin. A famous altcoin is Litecoin. Wallet. A wallet is a file that contains the private key of an entity. A wallet provides an interface to view and do transaction on the blockchain. Different wallets for different types of blockchains are used. Consensus. Consensus is a way for all the nodes in a network to agree on the shared state of the ledger. Some common consensus mechanisms are Raft, Paxos, Bayesian fault tolerance algorithm, proof of work, proof of stake, etc. Smart contract. A smart contract has details and permissions written in code that requires an exact sequence of events to take place to trigger the agreement of the terms mentioned in the smart contract. It can also include the time constraint that can introduce deadlines in the contract, also known as crypto contract and digital contract. It was first put forward by Nick in 1994. Transaction. An exchange of asset between two parties or entity is called as transaction. Transaction fee, a part of digital asset, that is cryptocurrency, that is charged from the parties who perform the transaction as a way to pay the network who invest their resources in order to sustain the blockchain. In a proof of stake based blockchain, the transaction fee is transferred to the miner once he validates the new block of transaction successfully. Blockchain fork, an act of blockchain software updated which leads to splitting of blockchain into two or more valid blockchains. There are three common types of forks in blockchain, namely hard fork, soft fork, temporarily or accidental forks. We will be discussing these things in detail in the upcoming lectures. 51% attack. An attack in which a single organization performs invalid activities on the blockchain network because they control network 51% of the network resources. Double spend, an act of using same digital asset twice. It is a common type of attack in blockchain. This type of attack becomes more difficult with increasing members that adds the new block to the chain. Confirmation. The confirmation is the act of successfully adding a transaction to the blockchain after verification. As a thumb rule, more confirmation means more security against a double spend attack. Testnet. As the name suggests, a Bitcoin test blockchain which is used by the network developer to carry out tests so that the main blockchain network is not affected. DApp. The full form of DApp is decentralized application, an application that is open source which is operated anonymously and has its data stored on the blockchain. It must have some kind of incentives for the members who help to construct the blockchain. ASIC. ASIC is application specific integrated circuit. These are all type of computers which are designed for performing a special task. In the case of Bitcoin, ASIC computers are used to solve SHA-256 hashing problem, which help to connect the new blocks to the blockchain. Now let us discuss about the different versions of blockchain. Blockchain 1.0, that is nothing but of the cryptocurrency. Blockchain version, its first application is based on cryptocurrency. This allows financial transaction based on blockchain technology 1.0, and it is being introduced in the year 2005 by Hal Finlay. Blockchain 2.0 is called a smart contract. The new version of blockchain came because there is a problem in the version 1.0, which was mining of Bitcoin, and the next version of blockchain is blockchain 3.0, that is DApp. After version 2.0, new version was introduced which includes DApps, which is known as decentralized app. A DApp is like a conventional app. It can have front-end writing in any language that makes calls to its backend, and its backend code is running on decentralized peer-to-peer network. Further, we can discuss about the types of blockchain. First, let us discuss about the permissionless blockchain. It is also known as trustless or public blockchain, or available to everyone to participate in the blockchain process that used to validate transaction and data. These are used in networks where high transparency is required. The characteristics of permissionless blockchain are: the permissionless blockchain has no central authority. The platform is completely open source. The permissionless blockchain has full transparency of the transaction, and it has heavy use of tokens. If you see the advantages of this permissionless blockchain, in this permissionless blockchain, everyone can participate. Only requirement is good hardware and internet. It brings trust among users or entities. That is the second advantage. And it has a high level of transparency as it is a large network. Finally, it has a broader decentralization of access to more participants. These are all the advantages of permissionless blockchain. When we look at the disadvantages of permissionless blockchain, it has poor energy efficiency due to large network, and its performance is very low, and it has less privacy as many of the things is visible. Let us now discuss about the permissioned blockchain. These are the closed network. Only a set of groups are allowed to validate transactions or data in a given blockchain network. These are used in the network where high privacy and security are required. When we see the characteristics of this permissioned blockchain, a major feature is a transparency based on the objective of the organization. Another feature is the lack of anonymity, as only a limited number of users are allowed. The next characteristic is it does not have a central authority, and it is being developed by a private authority. Let us discuss about the advantages of this permission blockchain. This blockchain tends to be faster as it has some nodes for validation. They can offer customizability. They have strong privacy as permission is needed for accessing transaction information, and as few nodes are involved, performance and scalability are increased in this permission blockchain. The disadvantages of this permission blockchain are they are not truly decentralized as it requires permission, risk of corruption as only a few participants are involved in this permission blockchain, and anytime owner and operator can change the rules as per their needs. These are all the disadvantages of the permission blockchain. So here I have shown the comparison of permissionless and permissioned blockchain. As I have told that in permissionless blockchain, the blocks that are requires no permission to join and interact with, and in permission it is not the case. The blocks require permission to join and participate in the consensus. If we see the characteristics of this permissionless blockchain, they are truly decentralized, transparent, and immutable. When we see the permissioned blockchain, they have a governance structure, they are private transactions, and they have authentication process. If you see the advantages of this permissionless blockchain, they are open to all, bring trust to all users, and they offers high security. When we go see the advantages of permission blockchain, they are extremely fast, scalable network, and offers energy efficiency. And the disadvantage of the permissionless blockchain is so slow in transaction speed, hard to scale, there is no energy efficiency in this permissionless see the permissioned blockchain's disadvantage. They are not truly decentralized since they have a governance structure. They have less transparency and partially immutable. Some of the use cases of permissionless and permission blockchain are, if you see the permissionless blockchain, the use cases are digital identity, voting, fundraising, or some of the use cases for permissionless blockchain. For permission blockchain, food tracking, banking, supply chain management, all these are permissioned blockchains. Let us further discuss the types of blockchain. Public blockchain. These blockchains are completely open to follow the identity of decentralization. They do not have any restrictions. Anyone have a computer and internet can participate in the network. As the name is public, this blockchain is open to the public, which means it is not owned by anyone. Anyone having internet or a computer with good hardware can participate in this public blockchain. All the computers in the network hold the copy of other nodes or block present in the network. In this public blockchain, we can also perform verification of transaction or records. The advantages of this public blockchain are the public blockchain is trustable. There are algorithms to detect no fraud. Participants need not worry about other nodes in the network. They are also secured. The blockchain is large in size as it is open to the public. In a large size, there is great distribution of records. The public blockchain is anonymous in nature. Hence, it is a secure platform to make your transactions properly at the same time. You are not required to reveal your name and identity in order to participate. It is decentralized, so there is no single platform that maintains the network. Instead, every user has a copy of the ledger. So these are all the advantages of this public blockchain. When we look at the disadvantages of this public blockchain, the main disadvantages are processing. The rate of transaction process is very slow due to its large size. Verification of each node is a very time consuming process, and the energy consumption is also of very high. Next, we look about the private blockchain. These blockchain are not as decentralized as the public blockchain. Only selected nodes can participate in the process, making it more secure than the other. These are not as open as public blockchain. They are open to some authorized users only. These blockchains are operated in a closed network. In this, few people are allowed to participate in a network with a company or organization. The main advantages of this private network are first is of the speed. The rate of transaction is high due to its small size. Verification of each node is less time consuming. Next is the scalability. We can modify the scalability. The size of the network can be decided manually. The next advantage is privacy. It has increased the level of privacy for confidentiality reason as the business require. The disadvantages of private blockchain are its security. The first thing is of its security. The number of nodes in this type is limited, so chances of manipulations are there. These blockchains are more vulnerable. The next is of centralized. Since it has a centralized structure, trust building is one of the main disadvantages due to its central stuck nature. Organizations can use this for malpractices. The next disadvantage is count. Since there are few nodes, if nodes go offline, the entire system of blockchain can be endangered. Type of a blockchain is hybrid blockchain. It is the mixed content of the private and public blockchain, where some part of the thing is controlled by some organization and other makes or made visible as public blockchain. It is a combination of both public and private blockchain. Permission based and permissionless systems are used. User access information via smart contract. Even a primary entity owns a hybrid blockchain. It cannot alter the transaction. The advantages of this hybrid blockchain are, the first thing is its ecosystem. It is most advantageous. It cannot be hacked as 51% of users do not have access to the network. The next advantage is its cost. Transactions are cheaper as only a few nodes verify the transaction. All the nodes do not carry the verification, hence less computational cost. The next is of its architecture. It is highly customizable and still maintains integrity, security and transparency. Operation. It has chosen the participants in the blockchain and decides which transaction can be made public. The disadvantages of this hybrid blockchain are its efficiency. Not everyone is in the position to implement a hybrid blockchain. The organization also faces some difficulties in terms of efficiency in maintenance. Next comes the transparency. There is a possibility that some can hide information from the user. If someone wants to get access through a hybrid blockchain, it depends on the organization whether they will give or not. So that becomes the major disadvantage of this hybrid blockchain. Next is of ecosystem. Due to its closed ecosystem, this blockchain lacks the incentives for network participation. The next type of blockchain is consortium blockchain. It is a creative approach that solves the need of the organization. This blockchain validates the transaction and also initiates or receives transactions, also known as federated blockchain. This is an innovative method to solve the organization needs. Some part is public and some part is private in this consortium blockchain. In this type, more than one organization manages the blockchain. The advantages of this consortium blockchain is a limited number of users makes verification fast. Hence, the speed is very high in this consortium blockchain. Next advantage is its authority. Multiple organizations can take part and make it decentralized at every level. Decentralized authority make it more secure. The next advantage is its privacy. The information of the checked block is unknown to the public view, but any member belongs to the blockchain can access it. Next comes the flexibility. The consortium blockchain is flexible, that is, there is much divergence in the flexibility of the blockchain since it is not a very large decision that can be taken fast. Let us discuss about the disadvantages of this consortium blockchain. All the members approve the protocol, making it less flexible. Since one or more organizations are involved, there can be different in the vision of interest. The next point is it can be hacked if the organization becomes corrupt. Organization may hide information from the user. Hence, the transparency is the major disadvantage in this consortium blockchain. Next is of the vulnerability. If few nodes are getting compromised, there is a great chance of vulnerability in this blockchain. So here I have shown the complete summary of the public, private, federated and hybrid blockchain which we have discussed so far. You can have a look on it. And that's all for today's class. Meet you all in the next lecture. Thank you.